Okay, this quiz is really just conceptual. It's giving you some other examples where a significance test is basically the bread and butter of the social sciences, of medicine, economics, and a lot of business studies where they talk about metrics and rubrics. They're kind of interrelated. So this stuff is widespread throughout our society. It may be one of the most widely used um, data gathering and analysis techniques out there, and very often we're not even aware of it. It's just there, and then products and ideas and whatnot are just plopped down on us. Here's one in psychology. There's been furors over this in social psychology. There's been accusations that one, it's not a science produced by those who are psychologists themselves because there's too many falsified or falsifiable type experiments which establish correlations because of sexiness of the results, but really there's nothing there. It's just basically pseudoscience. So the basic idea here: why would significance tests kill off many of the benefits of research into whatever sort? You might think, well, if they're going to do research as to whether or not a certain program, a pilot program for education, let's give free schooling to kids, no cost whatsoever, to raise them up. Would that be a good idea? Everyone would think so, yes, right? So then they run a test, and then they gather data. And then the problem is maybe they didn't do the test correctly, they didn't set it up correctly. Maybe their significance test didn't establish what it meant to establish. Or maybe they tweaked the data and they got something to be established and they didn't do a proper study. So any number of things can come out of this, good, bad, whether you're politically left or right, it doesn't matter. The point is, significance tests can be used to garner results either way. And the problem is that if it indicates a positive result, indicates significance, but doesn't establish it, what that means is you've got a correlation. Assuming you did your tests and your study and you interpreted your uh, results correctly, you're going to have correlation but not causation. Again, significance doesn't establish a result, it just establishes a correlation. What you want is further study. In line with that, again, I assume you guys have read this. Significance, if it establishes just correlation, we're on to two now, um, but it may give you no explanation whatsoever. And the problem is that if you have significance, meaning you have some kind of established correlation there, assuming again you did your tests and whatnot right, you still may have no idea what's really going on. So if you remember the example I used in the last lecture from the so-called science of beauty, when they measured differences in the height of your fingers, your ring finger being higher than your index finger, that seems to indicate higher symmetry and therefore beauty in terms of the overall person. And that, let's suppose they got that correct. Let's suppose they established that as a correlation across a wide range of subjects. Yeah, that still gives us no explanation whatsoever as to how that correlation occurs and if there is any causal relation between symmetry, which is supposed to be a key marker of physical beauty, and this asymmetry in the measurement of the fingers of your ring finger and your index finger. I mean, it's just a big unknown. Explanation is what you really want because explanation gives you a sense for why things are correlated. With just correlation, you're not going to have any explanation. In fact, if you want a classic example of this, the older view of the universe, when you actually look at the sky and you do experimental results, you track, say, the motion of the planets up there in the sky, and you're not going to be able to see it, just standing there. But suppose you got to back in the day, and they didn't have video cameras; they just had to watch carefully and track it over time. But if you had a video camera that ran 24/7, and you track the motion of the planets, and then you plot that on a graph, it's going to look like one of these things called epicycles. The planets go forward and they go backwards, and they draw these things that look like loops. So if you're sketching it, you put your pencil down on paper, you make it go right to left, it forms a loop, and then it forms another loop, and you go right to left some more, and it basically forms these. It's a cyclical type chain with these loops going from left to right in between. These are called epicycles. And when you actually track the motion of the planets visually over time, that's what it looks like. So it's thought that the planets don't travel in nice orbits. They travel in these funky patterns where they're doing like these cartwheel roundabouts, moving from left to right or right to left, whatever it might be. Okay, that gives you correlation between the motion of the planets and what you see, your measurements. But it gives you no explanation for why the planets are doing this cartwheel loop-de-loop roundabout. Turns out later that that's just an artifact of our motion relative to those planets. That the planets are not moving on those lines, but are actually orbiting in ellipses, circular ellipses, right? They're not making these loop-to-loops. That just happens because of the way in which our angle of viewing it in relation to the planet moves on these lines and gives it the illusion that it's moving in this cartwheel fashion. That's the real explanation for why that correlation occurs. That's why explanation is needed. Okay, next one is the more important one, 3. What does it mean for the estimate not to be statistically significant? That is, if the results fell just short of 90%. Okay, in this case, the P level is at 10%, right? So they're not doing the 1% level, which is the 3 sigma, 99, nor the 2 sigma, which is 5% level, 95%. Instead, they specify something else, 90%, which is the P level in this case is 10%, right? So the null hypothesis would be that in this case, they're talking about a program to keep people off the dole, meaning off welfare. So the null hypothesis would be that this program does not work, okay? And then you got to that's your hypothesis. Then you run the experiment. This is the pilot program, and you want to know if it works, right? Maybe you run it for several groups, maybe just one. They found that the results fell just short of 90%, right? And so the null hypothesis is the program doesn't work. The either or format is either the benefits are not 4 times as large as the costs for keeping people off the dole, or the null hypothesis is false. So the null hypothesis, more precisely, is not just the program doesn't work, but it doesn't produce 4 times as the benefits as the costs, which is, if you think about it, great. If you got this program that produces 4 times the benefits as what it's costing you, however you measure the benefits, that seems like a great program. The null hypothesis would be, in this case, not that the program doesn't work, but more precisely, it doesn't produce 4 times as much the benefits, okay? And then the either or format is either the null hypothesis is true and something unusual happened, in this case at the 10% level, or the null hypothesis is false. The problem here is if the results for this program fell just short of the significance, say 89%, why is it being rejected? Which in this case it is. Who specified the 9%? If it produces not as much as, let's say, 4%, but a little bit less than that, isn't it still a good program? Why would it be rejected solely at the basis that it fell short of the 10% P level? And that's part of the problem here in establishing the significance test. Who's deciding where the cutoff line is? What if they don't like it and they move it slightly? Instead of 10%, they say, oh, let's make it 11 to make our results now good. Oh, okay, now it's fine. 89%, it's just short, it fell, but now if we move it slightly, move the bar, then it's fine. This is part of the arbitrariness of how statistical significance works, and it very often is used in political, it's manipulated in that way in political and economic and other type contexts. After reading all this, what lessons might you draw from the article? Well, thinking critically can help you out. The basic idea from all this, correlations do not establish causations. Correlations is the playground of statistical significance. But how those things are related and whether or not they're genuinely related requires more investigation. So don't be deluded or fooled by the numbers. The numbers may be good initially, but you don't know how good they are. Okay? That's the bottom line for significance.